welcome back to ITQ Cloud Native Chronicles. We are still here at the Red Hat Connect Summit, and I'm joined here by a very special guest, Erik Zandboer of Pure Storage.
Hi.
Hi, Erik. Why don't you introduce yourself? Tell us what you do at Pure.
I can do that. So I work within Pure Storage for Portworx, which is like a small, I would say, independent group from Pure Storage, and I'm a cloud native architect, which basically means I handle all the technical stuff.
Awesome. So tell us a bit about Portworx. It's something to do with storage, I believe.
It definitely is. So where you see all vendors that have storage arrays deliver CSI and say, hey, this is our way to have storage surface up into Kubernetes. That's where we do things in a different way, right? We build a software-defined storage layer within Kubernetes and then look down at block devices for persistency. So we can use any Kubernetes on any block device, which means that wherever you go, whatever Kubernetes you have, whether it's in public cloud or private cloud, you always have the same Portworx layer. Only the backend storage is different, but that's abstracted away, which basically means you can now do things or cool things like replication between different storage array vendors, do replication between public and private cloud. So those are the kind of things that we enable at scale. Portworx does everything the Kubernetes way, so it's all YAML, right? Everything you do is through your favorite YAML code.
So I'm not sure if YAML itself is everyone's favorite thing, but it is certainly easier than having to configure different solutions all in their own different way. By pushing everything through Kubernetes, at least we do everything in one standard way. So there's something to say for doing things at the Kubernetes layer. Mm-hmm. This is, of course, different from how a lot of CSI drivers work. They operate in the Kubernetes storage abstraction, but you're going to have the different storage vendors have their own capability sets, have their own way of presenting the storage, have their own features they expose through their CSI driver. But in cluster solutions like Portworx, they abstract at a very different level.
That's the whole idea. And that definitely plays into the scaling thing as well. Because what we see now, we see a lot of traction of people that are saying we want to move away from VMware and Broadcom. We want to run our virtual machines within a container platform. But most CSI drivers built like a one-to-one connection. So previously in VMware, you could surface up 10 large block devices, and then you could carve out hundreds or thousands of virtual disks from those. Now you have to go to your storage administrator and tell him, well, we're going to run 10,000 virtual machines. So on average, they have 1 or 2 virtual disks. So get me 15,000 LUNs, please. You probably need to wake him up after that because, well, even though lots of arrays can actually do it, it's not a position where you want to be.
Yeah.
And when you look at Portworx, we built that abstraction layer right into the Kubernetes core. You feed it a couple of large LUNs and we can carve out tens of thousands of PVCs. Still using CSI, but terminating CSI within Kubernetes itself. So not having to go back to the array, ask it to carve out a LUN, have that surface up into Kubernetes, and so on. So also when you look at the number of operations you can do per second, that's where Portworx basically wins, right? So if you're building, breaking PVCs all day long, you can handle a lot of those CRUD operations way better than having to go down to a storage array to talk to its API. That's in a nutshell.
Yeah, and you can consume any underlying block device.
Yeah.
So that means local disks.
Yes.
It means I don't need to bring a big storage array to the table.
You don't have to. So you could use it for edge. We have larger customers that just use local drives. So Portworx, whenever you install it, you can build it and say, grab any empty disk that you find. It can do that. It will measure the speed of the disk. It will measure the size of the disk and then pool them together. So you might end up with a high tier and a medium tier and a low tier. And then through storage classes, you can actually tell them this workload should go in the high tier. This workload should be on the mid tier and limited to 1,000 IOPS because things like noisy neighbor, we can also counter for.
Yeah.
So all those things are captured within the source class, including things like the number of copies that you want, because especially on local disk, you will need multiple copies because, well, if a disk fails, you lose your data. So You can say, I want two replicas or 3 replicas. Everything works in the Kubernetes way, so it's all like majority of nodes. So if you have 3 copies, it will wait for 2 copies to be acknowledged back, and then the 3rd one can be async, because, well, we already have majority.
Yeah. So using this abstraction layer in Kubernetes, we can do basically hyperconverged storage. We can do HCI type solutions using local disks. There aren't that many other projects in the Kubernetes ecosystem that are capable of doing this. The only ones I know of is maybe Longhorn and Ceph in combination with Rook. It feels to me like a little bit of an underserved space. And if I'm not mistaken, Portworx is able to do a number of things that those other solutions cannot do. You already alluded to it earlier, replicating between clusters, for example.
Yeah. So we can do sync and async between clusters. Sync is also referred to as Metro, and for people that are well known in the world of VMware, they'll be like, oh yeah, Metro, and then we're stretching the cluster. Doesn't quite work that way. Our solution doesn't work that way because Kubernetes is slightly different, but it will render the same effect. So it's synchronous replication with an automated failover, including, well, not just PVCs, but also all of the Kubernetes objects. So that comes across as well. And it's the tiny simple things. It's like delete a PVC and by accident and you have a problem. Guess what? Portworx has a trash can. You can go down into the software-defined storage section and say, hey, this deleted PVC will be sitting there for a number of days. You can configure, of course, or turn it off. But you can say, hey, bring it back. And all of a sudden, Kubernetes will say, hey, I got a new PV that was previously deleted. You claim it to your workload and it works again.
Yep.
So it's the simple things that matter sometimes.
Yeah, and operationally that can save a lot of headaches. And I have messed around with PVs and persistent volume claims, and I know what a hassle it can be to have to do that manually. On the bottom end, But Portworx does more than just creating the storage abstraction. There's also a larger suite of product functionality around backup and restore, disaster recovery. Tell me a bit about that.
So the base product is Portworx Enterprise. And we also have something we call Portworx CSI, which is like really not so well chosen name, I would say, because that is the pure storage CSI driver. So that's the old way of doing things. But Portworx Enterprise is the base product. Then we have DR as an add-on, which allows you to have 2 separate clusters, run synchronous. Within 10 milliseconds, you can do synchronous, or for larger distance, you can do asynchronous, a replication between clusters. And then there's PX Backup as well. So that's a separate product. But the nice thing about it is that PX Backup is actually it's a control plane tool, right? Whenever you see like a modern presentation of PX Backup, they will always tell you that, the backups flow through this solution. And well, actually it doesn't, because PX Backup just sits on the sideline and tells Portworx, the data plane, tells it to, hey, grab this data, move it over there. That's backup and restore for us. So we're basically telling the Portworx system how to behave in order to do backup and restores, which is like a really efficient way of doing things. We have had customers that had issues where they said, our backup solution makes a snapshot of a disk. That's a wise thing to do. But then they create a mirror copy before backing it up. And then our quorum will not agree, right? So the thing will run out of quorum and everything breaks. And I'm like, we create snapshots on the Portworx layer. Kubernetes doesn't even see those. So they're copy and writes. They're just deleted afterwards. Frictionless, painless. And it just works.
So we're at a Red Hat event. So Pure has a partnership with Red Hat, as do we as a consultancy. What makes that partnership with Red Hat so valuable to Pure and to the Portworx use case in particular?
So when you look at the way that OpenShift basically enables virtualization, or basically OpenShift just is, it can run like anywhere, right? It runs in public cloud, it runs on private cloud, it runs on different types of environments. And guess what? We do the same thing, but then for storage. So that's more or less a match made in heaven. Because, well, OpenShift follows Kubernetes, scale out everything, Portworx works in the exact same way, scale out everything, but for storage. So it just works.
So I can take my storage kind of configuration as part of my application architecture, and it becomes portable. If I'm running, I can run Portworx on any Kubernetes, and if my storage abstraction is always the same, and my application becomes even more portable, instead of having to rely on the specific differences between CSI drivers all found in different clouds or on different infrastructures, Portworx abstracts all that away, because we're using one layer to do the storage abstraction.
Yeah, not to mention when you have different array vendors, try set up replication between a Dell and a NetApp, or a Hitachi and a Pure. It won't work, right?
Yep.
But with Portworx, because it's the same thing, that wherever you are, it just works.
So you can leverage the investments you've done in your storage vendors.
Yeah, and even though we're part of Pure, we are storage agnostic, which means, well, we prefer if you run Pure storage.
Of course.
There are some cool extras you get, like with Autopilot, you can automatically scale storage as you run out of storage. You can do that for the PVCs always, but you can also do this for the underlying disks that form the pool if you have a supported infrastructure. And guess what? A Pure Flash array is one of the supported infrastructures. So if you build a new cluster or you add worker nodes, Portworx can talk back to certain infrastructures like public cloud, VMware, or Flash array, and automatically carve out disks, feed it into the system, and grow the pool all automated. So that's very important for customers at scale.
Yeah.
And it's very important for customers in public cloud, because if you think you'll need 100 terabytes, you pay for 100 terabytes. How cool is it if you can just deploy 10, and then when it gets full, it automatically grows?
Yeah, without having to
save
pay
you a lot of money.
Yeah, without having to pay up front for all that cost, it's just dynamically added.
Yeah.
And this translates to the more efficient use of storage investment on the on-prem enterprise space as well. Yep.
Oh yeah.
Yep.
Yeah. And like I always said, so Portworx was there before Kubernetes. We were building storage into containers when no one cared. Right, that's where we started out. So that was like Mesosphere, Docker Swarm. And now no one knows that anymore, because if you say, what's a container orchestrator? People will say, oh, Kubernetes. Can you name a second one? No.
Not anymore.
Right, so yeah, we deprecated Mesosphere, and we're just focusing on Kubernetes today. But again, this is what 100% of the people are using when you run containers. So it makes sense.
Yeah. So there's a partner ecosystem around Red Hat and around Pure. We're a Red Hat, ITQ's a Red Hat partner and a Pure partner. There's a lot of opportunity in the market because the skill sets required to get all of these layers working together. It's becoming more common, but it's still relatively uncommon. How do you see the partner landscape, and where do you see us going, in the next 3 years when it comes to skill sets, the market, customers?
So that's an important thing, right? So if you're considering to move from VMware to OpenShift, you can go out to your VMware administrators and tell them, hey, look, different GUI, have fun. That probably won't work, right? So you need to start early with training. And it's really cool that you now have containers and VMs in the same platform, right? So when you run one of our labs, we run like this monthly lab, and there you can play around with it, and we provide you with an application in there that runs in a VM and in a container, happily together. But the platform is not VMware; it's different. And when it comes to the partner landscape, of course, you need a partner that knows about OpenShift virtualization. It helps if you also know VMware. And you have that nailed down really well, right? So if a customer wants to go OpenShift, they can talk to you. If they are happy VMware customers, but not so happy anymore and are thinking about moving, same story.
Yeah.
So I think it's going to be vitally important that people have knowledge on both, or partners have knowledge on both, right? And then can assist customers. Very often you hear customers that say oh, we want to move away from VMware. And I'm like, why don't you move away from 80%? Take the low-hanging fruit, move that over, but VMware ESX, right, is still the one to beat because it has a gazillion features. It works really well. It's enterprise ready. Some workloads may not translate today. They will probably tomorrow, but why bother? Just get started, especially when a renewal is on the horizon. That's when the prices go up, right? And we've seen several lawsuits, right, in the Netherlands as well, where companies are saying, "Hey, VMware, we're dragging you into court because we want support." And then they go like, "Okay, yeah, the judge said 2 years of support." Then you have a really massive deadline. That is when things will end, right?
Yeah.
So you need to work towards that, and you need to take your time because it's gonna be a bumpy road, right? It's not like, oh, I click this button and I migrate 30,000 virtual machines as some customers are doing. It's a crazy number, but it really takes some planning. It's not as easy as it looks.
But even if you want to stay in the Broadcom ecosystem, even there, vSphere has a Kubernetes component there as well. And even there, I can recognize use cases where Portworx can be an added value even on top of that stack. Because Portworx can do certain storage things, in and outside of the Kubernetes layer that no other technology can. So even customers staying on vSphere, there's a very interesting use case around Portworx and about especially using pure storage in combination with Portworx. It's still a very powerful formula, regardless of which vendor platform is being used around Kubernetes.
Oh yeah. I mean, we see customers, we see managed service providers that say we put everything on VMware, including OpenShift. And guess what? Portworx can actually use VMware as one of the infrastructure providers to automatically grow stuff. So it will talk to your vCenter, carve out LUNs if you add worker nodes, and grow the pool automatically. So the integration is definitely there. We even see customers that say, no, we're running like an active metro cluster between two sites, and we're putting OpenShift on top of that. And we use that as a failover. Do I need DR in that case from you guys? And I'm like, no, you're running one cluster. VMware takes care of any site failures, any logical failures, so you're good.
Yeah. Okay, so rounding off, it's the end of the day. I've already got my wine.
Yeah.
I don't know what you did with your beer. Left it behind.
Left it behind.
Yeah. So it's time to party.
Yep.
Thank you for your time.
Sure.
We're going to be talking to each other a lot more in the future because there's great work to do across all of these different platforms, across all of our common customers. So thank you for your time, Erik, and we'll talk to you soon.
Sure. It was nice to be here. So thanks for the invitation, and we'll talk soon.
Cool. Thank you. So this is Robert for ITQ Cloud Native Chronicles, signing off here from Red Hat Connect Summit. See you next time.